Hi everyone. In last session, we have discussed about carvings, singlet carvings and triplet carvings, their structures and their different properties we have discussed. Today, we'll discuss about nitrene intermediates. Nitrene intermediates, also called as imidogenes, and these are nothing but neutral chemical species in which nitrogen atom is bonded to monovalent atom or group. Nitrogen atom is bonded to monovalent atom or group and is surrounded by 6 electrons. There is sextet of electrons called or is called nitrene intermediate. What is nitrene intermediate? Neutral chemical species in which nitrogen is bonded to one monovalent atom and is surrounded by sextet of electrons called nitrene intermediates. Okay, it is similar to carbenes. Here also we have singlet carbenes and also triplet carbenes. Here, here I am writing singlet carbene first. Singlet nitrene, and here triplet nitrene. For this, the important thing is spin multiplicity rule. Already in previous class only I given spin multiplicity rule. Spin multiplicity rule. Here I am writing spin multiplicity. Spin multiplicity. Spin multiplicity equal to n plus 1. N plus 1. Spin multiplicity equal to n plus 1. For singlet nitrines, n plus n value must be 1. So here n plus 1 equal to here 1. In triplet nitrines, n plus 1 must be equal to 3. So here, therefore, n value how much? N value equal to 0 here. Here, n value equal to 2. So n value 2 means it is nothing but unpaired electrons. Where n, here n is nothing but what? Unpaired. All this explanation in last class only again. Unpaired electrons. So from this information, we can draw the structure. We can draw the structure. In this, nitrogen also contain 2s and 2p orbitals. 2s and 2p orbitals. 2s and 2p orbital means here one box I am writing. Here 3 boxes. Otherwise, total how many boxes we can expect? Total 4 boxes here. One 2s box or 2s orbital, 3 2p orbital, 2px, 2py, 2pz. Here n equal to 0. N equal to 0 means no single electrons are present, no unpaired electrons are present. So as to get no unpaired electrons, we have to write electron configuration. Electron configuration, 2s2, 2p3. 2s2, 2p3 is electron configuration of nitrogen. Here among these three, here one electron is bonded to, afterwards I'll give what is hybridization from this only. Is once listen here, this electron forms a bond. This is the R electron, this is nitrogen electron. Then remaining how many electrons here? 2, here 3, 4, here 5. See here 1, 2, 3, 4, 5 electrons. 2 plus 3. This is again electron pair. And these 2 electrons are present, no? So these 2 electrons we should write in one box only, because here unpaired electrons should be 0. As to get 0 unpaired electrons, I written this electron which is present in this box in this. So total number of electron pairs are how many now? Total number of electron pairs here are total number of electron pairs. Total number of electron pairs are equal to here 3. Here one is bonding electron pair. These two are non-bonding electron pairs, otherwise lone pair of electrons. So if total number of electron pairs are 3, then hybridization is sp2. sp2, but here because of presence of these two lone pair of electrons, shape, what is the shape or geometry? 2 lone pairs, otherwise 2 LPs. LP means lone pair of electrons. 2 lone pair of electrons containing trigonal planar we can write. Trigonal planar. This is the shape, otherwise geometry. Here two lone pair of electrons containing trigonal planar. For this we can draw a structure like this. N, here one R. This is one sp2 hybrid orbital. This is another sp2 hybrid orbital. Here two electrons are present. See here these boxes I am writing in this way. So here this is one box sp2 hybrid. After mixing, intermixing all these orbitals, all these orbitals means one s orbital, two p orbitals, like up to here, this is one more orbital. This is unhybridized, otherwise pure orbital. It is unhybridized or pure orbital. This is like orbital structure. And here this is one sp2 hybrid orbital. This is another sp2 hybrid orbital. This also sp2 hybrid orbital, but here there is a bond pair. This is monovalent atom. These two are electron pairs which are not participating in the bonding, or lone pair of electrons we can say. And here as per the properties, see here all electrons are paired electrons, no unpaired electrons are present. So that here we can say this is the diamagnetic. And all electrons are present in these pairs are present in boxes, means orbitals. Two electrons are present in the same orbital. That means this is unstable. If electrons are present in two different orbitals, there exists some less repulsion, so we can say that is more stable. But here electrons, these two electrons are present in the same box. Here also two electrons are present in the same box, so that we can say this is unstable and diamagnetic. Mu value, magnetic momentum value equal to 0 here. What is the mu value? Magnetic momentum mu equal to 0 we can write as per the formula. Under root n into n plus 2 is the magnetic momentum formula. N value is 0, so that mu equal to under root 0 into 0 plus 2 means it is 0 only. So this is about singlet nitrene. It's about singlet nitrene. Then triplet nitrene also same thing. But while writing electron configuration, there is boxes form. First again I am writing in the same way. One s orbital, then three p orbitals I am writing. After that how it is intermixes with each other depends on hybridization and the total number of electron pairs. See here, as to get two unpaired electrons, we have tried the configuration. Then after we can go for intermixing as to get hybridization. So here one electron, it is bonded with R group. This is monovalent atom. And here as to get two unpaired electrons, I am writing here 1, 2. Here 1, 2, 3, 4. This is pair of electrons. This is one lone pair of electrons. These two are present in two different boxes, not like this. These two electrons are unpaired electrons. Why I written here unpaired electrons? Because we are discussing about triplet nitrene. For triplet nitrene, n plus 1, that is spin multiplicity n plus 1 equal to 3. So that n value equal to 2. As to get two unpaired electrons, I written here this structure, orbital structure. So for this, here total number of electron pairs I am writing first. Based on total number of electron pairs, in previous classes I discussed about hybridization, how we can decide hybridization based on number of total number of electron pairs, bonding electron pairs and lone pair of electrons. Should not include pi electrons. Here anyhow pi electrons are not there. So total number of electron pairs here, this is one bonding electron pair, this is lone pair of electrons. These two are single electrons, should not be considered. Only pairs. In this, say here this box contain one lone pair, this box also contain one lone pair, and this is one bond pair. So three total number of electrons you are considered here. But here these two electrons are separately arranged in two different orbitals, so that you should not consider it as pair. Two single electrons only you have to consider. So that total number of electron pairs are equal to 1, 2, only 2. Therefore hybridization is sp. Hybridization is sp. And what is the shape we can write? Here only one lone pair of electron is present. One is R group, then here nitrogen, then this is one sp hybrid orbital. Like this we can intermix this orbital and this orbital. These two I am intermixing. These two orbitals I am writing separately. these two unpaired electrons containing orbitals are pure orbitals. This is these two are pure now, means which are not participate in the bonding or sorry hybridization. They are pure orbitals. This is the bonding electron pair with R. This is lone pair of electron. So lone pair of electron containing orbital, that is sp2 sp hybrid orbital, not sp2 sp. This is sp hybrid orbital. And there are two different boxes we have. Like this I am writing. Here one single electron is present. Here one more. Like this I am writing. This is the two p orbitals, pure p orbital. This is one pure p orbital. This is another pure p orbital, which contain electrons, single electrons. Here also we can write these two are lone pair of electrons containing. One is empty orbital. Here we can write like this. But here there is no electron. This is empty. This is empty orbital. Here they are not empty orbitals, which contain one single electron. One single electron. So here shape what we can say, sp hybridization means linear shape. But here one lone pair of electrons containing linear. One LP, lone pair of electron containing linear shape. Like this we can write. This is about singlet nitrene and also triplet nitrene. So last session we have discussed about carbene, singlet carbene and triplet carbene. There also I given very clear explanation how to write structure and shape and which is stable, which is unstable, why it is so. All those things I given same explanation here also. So if you write stability and magnetic property here means here because of presence of these two unpaired electrons, this is the paramagnetic. This is the paramagnetic. Paramagnetic and n value is 2. Lone pair of single electrons are 2. So that mu value is how much? Mu equal to 2.8 approximately bm Bohr magnetons. 2.8 Bohr magnetons. For this paramagnetic momentum already I given formula. This is the formula under root n into n plus 2 Bohr magnetons. This is the formula. Here n value is 2. So if you substitute 2 value, approximately we can get mu value 2.8. And here this is stable. Triplet nitrene is stable. Why it is stable? Because two single electrons are present in two different orbitals, unlike singlet. In singlet, one orbital only contain two electrons with opposite spin, so that here there is a repulsion existed between two similar charges. Here two different boxes are taking two electrons, single electrons, so that here repulsions are less, so that it is stable. Here questions are which is stable, which is unstable, which is paramagnetic, which is diamagnetic, and which is having sp2 hybridization, which is having sp hybridization. How we can get the singlet, how we can get triplet. For this spin multiplicity rule we should know. So this is about nitrene intermediate, but generally it is formed in second year part in amines chapter. I think you have one reaction, that is Hofmann degradation reaction. In Hofmann degradation reaction, we can expect the formation of nitrene, that I will give Hofmann reaction, Hofmann degradation reaction. Otherwise, we can say Hofmann hypo-bromide reaction. In that formation of nitrene they are given. Simply, I'll explain formation of nitrene in Hofmann reaction. It is there in the second year syllabus. Wait a minute. Formation of nitrene. Formation of nitrene in Hofmann's reaction. Otherwise, Hofmann's degradation reaction. Degradation means number of carbons in the reactants and products. If you observe, number of carbons becomes less in product side compared to reactant side, so that we can say it is degradation. So here Hofmann hypobromide reaction. In this amide we should take. See here R C double bond O N H2. Here there is a lone pair of electron which is already present in nitrogen. Whenever it is treated with bromine in the presence of sodium hydroxide or potassium hydroxide, so here two bromines are there. In this reaction, one hydrogen is eliminated with bromine and as HBr. This HBr combines with sodium hydroxide and forms water and NaBr. That is different. Here just you observe how nitrene is produced. Here N, here hydrogen, then there is a lone pair of electron, here bromine. This is N-bromoamide. N-bromoamide. In next step, in the presence of which one more already bromine is there. Sodium hydroxide or potassium hydroxide we should take in next step. Here from sodium hydroxide I am taking OH minus. See here and NaOH also we can write directly NaOH. So here this electron pair is move with the bromine. Along with bromine, it combine with the Na plus here, so that NaBr is eliminated. And here this hydrogen leave from here without taking electron pair. So that this hydrogen eliminated as H plus now combines with the OH minus and forms water. So from this we can get nitrenes here, or C double bond O bond N, here electron pair, here electron pair. This is the nitrene. This is the nitrene intermediate. This is important. What is the intermediate produced in Hoffman hypobromide reaction? Means this one. See here, as per the definition, it is neutral species in which nitrogen is bonded to one monovalent. This is R C double bond O is combined with nitrogen with one bond only, so that nitrogen is bonded to one monovalent atom or group, and it is surrounded by 6 electrons. See here 6 electrons of it is here 2 electrons, here 2 electrons, here 2 electrons. These are the lone pair of electrons and this is bonding electron pair. Total number of electron pairs if you observe from here to here, this is a valency. Only 1, 2, 3, 4, 5, 6, so that it is nitrene intermediate. Then after the different reactions means there is a rearrangement takes place. Here how it is rearranged means this one electron pair shifted here, so that carbon atom number of bonds becomes more, so that immediately this R group shifted from here to here. So we get C double bond O, here double bond N R. This is alkyl isocyanate. From this again you can get if you take two potassium hydroxides here I am writing KOH, here KOH. Like this this is eliminated as RNH2. RNH and H means RNH2 means here amine is produced, primary amine is produced, and here K and K2 minus K2 CO and O CO3. K2CO3 is eliminated. After elimination of K2CO3 we can get primary amine. This is the Hoffman hypobromide reaction, otherwise Hoffman's degradation reaction. Why it is called as hypobromide reaction? Because NaOH and Br2 and reacts with each other, we can get hypobromide. That is a reagent. So that you can say it is Hoffman's hypobromide reaction, otherwise Hoffman degradation reaction. See, you can observe here in the beginning reactant R group and one more carbon is present. But in the reaction sequence, if you observe at the end, here R, this CO is missed here. This CO is missed, means number of carbon atoms decreases here. So that we can say it is a degradation reaction. It is there in second year amines chapter. There the nitrene intermediate, means here about nitrene intermediates, if you have some knowledge, then it is very easy to understand the same reaction in second year.